each of those are divided up into sensory or motor tracks. You can also communicate or connect from left to right in the white matter and gray matter. These are called commissures. So the commissure of the gray matter has this central canal, this opening in it. CSF is also going to flow through that central canal, as well as around the spinal cord in the arachnoid space. So you'll notice there's little rootlets coming off of the gray matter. These rootlets come together to form roots of the spinal nerves. So there's a ventral and dorsal root. Roots form together or join together to create that spinal nerve.
So can you explain again how it's divided in between sensory and motor, like where those divisions are exactly?
In reference to the gray and white matter, or the roots?
Both.
Both. Okay. So I think this is a later slide that we can talk about. Yes. So think of it this way too. So the white matter is going to have columns, meaning it's going to be information going up and down, kind of like an elevator. So if information comes in the thoracic spine and it needs to go up to the brain, that it's going to go through one of the columns of the white matter up towards the brain. There's also columns going downwards in the white matter. So if you need to make a command to your leg, your brain's going to send it through one of those columns down that elevator in the white matter to the area that it's going out to. Gray matter is going to send that information outward. So gray matter, the white matters, let's just, instead of going back and forth, let's just do white matter for right now. So divisions of white matter are going to look like this. So anything blue is an ascending tract, so information that's coming in and going up to the brain. Anything red is a descending tract, or funiculi. Right? So you don't need to memorize each of these, just be aware that the white matter is divided up in this way between these ascending and descending tracts within those columns. Okay? So that's the division of the white matter. The gray matter, depending on which horn you're talking about, is going to be either sensory or motor. So the ventral horn, the anterior horn of the gray matter, is going to be motor, to output information. The dorsal horn is going to be sensory information. So I think of this like most cars have the engine in front or the motor. So think the motor in the anterior in the front. And then when those roots combine, now you have a mixed nerve. So prior to that, it's motor from ventral horn, and it's sensory from posterior horn. Those join together and form your mixed spinal nerve. Does that make more sense? So again, the white matter, different columns. Those columns have ascending and descending tracts, like that picture we looked at with the red and blue. Also note there's commissural tracts going from left and right, like we talked about. So to kind of summarize, what are the two different areas of the spinal cord?
The gray matter.
Yeah, the gray matter, this H shape, it's deeper in, and then on the outside of that, white matter. How do we divide up the gray matter?
Sensory and motor? No.
there is sensory and motor. So motor is on which portion? Ventral, the more anterior. Sensory is posterior, dorsal. What are these projections called specifically?
Horns?
Horns, yeah. So depending on ventral horn or dorsal horn, we're giving rise to motor or sensory for the gray matter. We also have fibers that cross from left and right across this connection. What do we call that?
Commissioner?
Yeah, commissural connections. So when something crosses from left to right, it's called decussation. So going from left to right. So just a term to know. What's the opening in the middle of that gray matter?
CSF, but it's canal.
Central canal, yeah, and the CSF is, there's some CSF, cerebrospinal fluid in that canal. Okay, so that's gray matter, yeah.
Do the commissures go across the whole thing or just the gray?
You can either have commissural tracts in the white matter or the gray matter.
Okay, so it's not like
Yeah. So
both at the same time.
no, and depending on what nerve tract we're talking about is whether they cross or not. So that's gray matter, white matter around the outside. Actually, sorry, go back to gray matter for a second. So what's going to come off of the gray matter at each of these different vertebral segments? Yeah, these roots that are initially rootlets, so these little rootlets come off, form a root. Are the roots mixed?
No.
No, they're either
Sensory.
sensory or motor, depending off if they're coming off ventral or dorsal horn. Okay. So again, ventral horn and the ventral root is going to be what? Ventral up front, motor. Dorsal horn, dorsal
Sensory.
root's going to be sensory. And then when we combine those roots, we now have a mixed nerve, and now it's called what? What is this now?
Nerve.
The spinal nerve, right? So, and whatever segment you're coming out, so it could be the C7 spinal nerve, right? Formed by the C7 dorsal and ventral root of the spinal cord in that area. So that, yeah, got that, kind of visualize gray matter, what it looks like, forms these roots. Note that the dorsal root has a ganglion, dorsal root ganglion. And what did we say a ganglion was?
Bundle.
Collection of cell bodies in the peripheral nervous system. So in the central nervous system, collection of cell bodies is called a nuclei. In the peripheral, it's a ganglion.
That being said, there can still be cell bodies found in other places, right? This
Right,
is just
it's when you have a distinct collection, you know, and you could even have this enlargement of the
Wait, what you said is called,
a ganglion,
what was the other one, not?
Nuclei.
nuclei.
Oh,
Yeah,
okay.
and that's in previous ones. But, white matter. So white matter has. Sorry, I should point out with the gray matter in the thoracic area. Don't forget you can have that lateral horn too. What's your question?
Once you leave the spinal cord, like exactly the
Like
spinal
from
cord,
here out.
is it peripheral?
Correct. Okay. Yeah. Good question.
So as soon as they join, at that point, it's considered.
These rootlets are considered peripheral nervous system. Yeah. And as soon as it exits that boundary. Okay, so white matter, it has columns, so vertical columns or funiculi, so know both names. And within those columns, you have different tracks. So you have a ventral, dorsal, and lateral track, or anterior, posterior, whichever term you want to use. And within those columns, you have different tracks. Some of the tracks are ascending information up to the brain or higher areas of the spinal cord. Some of them are descending. Okay? Again, you don't need to name each of these tracks, but understand that that's how those columns or funiculi are divided up. Any questions on spinal cord?
Oh, no.
No, it's stupid, I'll wait till later.
No, please ask.
No.
I'm used to stupid questions.
Yeah, but I don't want to embarrass myself.
Why do you look at me?
I didn't look at you.
You look right at you.
Jesus.
Okay.
I got a question. Why do you
Because you should take it.
So like, let's say like if someone got in like a really bad severe car accident and like, doesn't matter like where, why are you giving me that look when I ask this question?
Look at it, he has his hand in the zip and everything.
I know. Like, does it matter like where on the spinal cord, like if it's like severed or something where you become either a quadriplegic or just like,
That's a good question.
well,
Yeah,
I felt
yeah,
like
it
it was
depends on the
stupid.
level, right?
I felt like it was stupid.
So this area of the spinal cord and down controls basically that area of the body and down, you know? So if I cause damage, well, it'd have to be somewhere in here. Then from that area down, it's gonna be affected, so paraplegic. Higher up you get, more you're gonna affect up to cervical quadriplegic. There's obviously exceptions to that. If we're talking just severed, then that simplifies it, and yeah, everything there down no longer has nerve function. Obviously, you could injure a portion of the spinal cord and affect just those tracks or
So,
something like that. It's not always that simple. However, yeah, level-wise is gonna affect there and down. Yeah.
And like, what kind of like brain damage will you get? Like, if you kind of like damage the, like right there, like at the neck. Obviously, not only will
Your
you-
question is if you damage your
Like,
spinal cord,
well,
what
no.
kind of brain damage
Will,
will
like,
you get?
will you get any like type of like brain damage where since you can't like,
I mean, you could affect ascending tracks, so in that sense, you could limit the function going to the brain, and sometimes that's terminal, sometimes it's not, right? I wouldn't term that brain damage necessarily though, because it's not damage to the brain tissue itself.
How close are they getting to spinal repair? I feel like every few years you hear something about.
It seems like they come up with new stuff. They're always, kind of on the edge of something new, and it improves. People's outcomes continue to improve. Repair-wise, I don't know. In my opinion, it's going to be stem cells. They'll figure out how to basically just regenerate the tissue.
I was just gonna ask if they can too.
What's that?
Stem cell.
Yeah.
Because
Yeah.
they use it for, they have procedures out there, my mother-in-law had it.
Yeah, it's becoming more prevalent, and for some things it seems to work really well. Other things it doesn't seem to work so well. But it's certainly, they're starting to get it figured out. I mean, technically, someday you could just grow, you could take a person's cells and create spare parts for everything in their body, and then you don't have any sort of donor rejection because it's your own tissue. Or if you have damaged tissue, you could heal that tissue. That's the potential of it. It's obviously off a little bit still, but
I think it would be
Science.
robotics.
I think it'll be a combination of that. I think it'll be 3D printing. I mean, they've used 3D printers to print tissue. So if you
Skin grafts.
use like 3D printing combined with stem cells, and then maybe throw in some sort of robotic function there. Yeah, that's the
million
future.
dollar man.
I think the problem is we tend to underestimate the complexity of the human body. There was a survey done in the 70s before we landed on the moon, just of the general population of the U.S. The question was, which do you think will occur first, a cure for cancer or land on the moon? And the vast majority said cure for cancer. We've been to the moon so much we don't care anymore. We still
We
don't
know
have
what
a
it
cure
looks
for
like.
cancer.
That's true.
You can get out of class for that.
Let's start that discussion.
We are not in debate.
Yeah, so there's all kinds of great stuff, in the works, but the human body is hard. Right, where are we at? Spinal nerve. So 31 pairs, like we said, rising from the spinal cord. And we now know how those spinal nerves are formed by dorsal and ventral root. So 5 groups, different regions: cervical, thoracic, lumbar, sacral, coccygeal. There's 8 pairs of cervical spinal nerves, 12 pairs of thoracic, 5 pairs of lumbar, 5 sacral, and 1 coccygeal, 1 pair of coccygeal. Remember, they're all paired coming out left and right. We are symmetrical. We're supposed to be left to right, so we need symmetrical innervation left to right. So here's kind of where we see this joining occur. So here's intervertebral foramen, right? So the bony exit from the vertebral column. At that area is where you're going to have that joining of the dorsal and ventral root as it comes out the foramen. Okay, so just anatomically, that's where that's occurring. So as those spinal nerves exit in the thoracic area, they just go straight out, run along the intercostal space, and innervate kind of directly out in that area. In the cervical, lumbar, sacral, after they exit, they start to branch and interconnect. So think of it just like getting off the highway. So if I-25 is the spinal cord, you can take exits off of I-25, and then there's side streets, there's interconnecting streets, it starts to branch and all that. These would be nerve plexus, where you have that interconnection and that branching. So like I said, T2 through T12 thoracic area doesn't have plexus, just comes straight out. But we'll see in other areas, there's cervical plexus, brachial plexus, lumbar, and sacral. So cervical is obviously in the area of the neck. Brachial is part of the neck, part of upper thoracic, like T1, and then goes out to the brachium into the arm, that's brachial plexus. Lumbar plexus is lower back out to the leg, same with the sacral. So we'll start with cervical plexus. So for testing, I'll expect you know the root areas or the sections that contribute to the different plexus. So for cervical plexus, you'll need to say C1 through C4, and actually in addition to that, C5. So you can just say C1 through C5 for cervical plexus. And then know general area that it's going to innervate, and the distal nerve branches that it produces. So cervical plexus, C1 through C5, it's going to innervate the neck. So cutaneous nerves, mostly sensory to the skin of the neck and the back of the head. Also forms the phrenic nerve. Phrenic nerve goes down to the diaphragm. So it's motor control of your breathing of that diaphragm. So inferior to that, brachial plexus, this is C5 through T1. So the spinal nerve from 5th cervical, 6th, 7th, and 1st thoracic. All of those spinal nerves are going to contribute to this brachial plexus down through here. Okay, so it's going to go underneath the clavicle, down into the arm. So it forms axillary nerve to the deltoid muscle, musculocutaneous nerve to the bicep brachii and the brachialis muscle, radial nerve, median nerve, ulnar nerve. Radial nerve is going to go to the triceps, median nerve to the flexors of the hand and wrist, ulnar nerve, also flexors of the hand. So this is a simplified drawing of the brachial plexus. So spinal cord is in the central here. You would see a brachial plexus coming off each side. So you start with the roots, right, from each corresponding area. So C5 through T1 roots. They can join together, go straight out, interconnect to form trunks. Those further branch into divisions, then cords, then branches. The branches are the named nerves that go down into the arm. So you should be able to, in order, lay out roots, trunks, divisions, cords, branches. So real teachers drink cold beer. Make sure you start from the spinal cord and work outward. So if this is a reference to me, this is my right arm. If I go the other way, I need to make sure I go in that order too, right? Real teachers drink cold beer as they go out.
So no matter what, it's RTDCB. Yeah.
Starting from midline. Yeah. Lumbar plexus, L1 through L5. The inguinal nerve. So this goes sensory to the thigh and genitals. Genitofemoral nerve, sensory to scrotum, labia, and anterior thigh. Femoral nerve to the quads and sartorius, so knee extensors. Sacral plexus, L4 through S4. Superior and inferior gluteal nerve to the gluteal muscles. Sciatic nerve, the hamstrings, posterior thigh, leg muscles. Pudendal nerve, sensory to the penis, clitoris, labia, and anus. I used to make a joke, don't hurt this nerve. I'd be a real bummer.
What?
But people wouldn't laugh, they just kind of looked at me awkward, so. I feel like this would have been the class that it would have landed. It's too bad.
You told us about the joke that you don't tell anyone.
Well, because it used to just bomb, and I'd stand up here and like get
Well,
red,
tell
like
us,
they're joking about
like,
clitoris
I know
and
like
stuff.
3 people will like
But this
laugh
class
at
is
the
really immature, so that's
So let's,
it's too late.
it's never too late.
Are you guys, how many people have to take AMP2?
I'm taking it.
Do you teach
Well,
that?
you're a loser because you took him.
I do, I haven't in years. I don't teach it next semester, actually, I just got a teaching assignment, so I'll just
Google.
it listens to me randomly. I'm not saying anything.
It's your FBI agent.
Probably, just because I'm talking about penis.
You're gonna get arrested.
You're gonna get arrested. There are children present there.
Why is this teacher talking about penis?
So there's another professor that we went to school together, Dr. Bantock, so he teaches AMP2, although I don't think he is next semester. But he uses my notes. But when I did teach AMP2, we got to, and I'm just gonna tell you guys, don't tell anybody if they take Bantock next
All right,
semester.
I'm
So-
not recording.
Although I don't think he does the joke. I think he changed it. I think that appears. But we get to reproductive system. And so you know, you name an organ, you talk about general size and stuff. You know, the kidney is about the size of your fist or whatever. So we get to the penis, and on the slide, I put that the average length. It started out reasonable, and now I think it's up to like 12 inches. But I just keep a straight face and write it out, like average length 12 inches. Move on to the next. I just watched the reaction of the penis. People are like,
What?
okay, for real?
Does anybody ever raise their hand?
You'd
Yeah,
be like-
sometimes people are like, I don't think that's right. There's always some jerk in the class. It's like,
But you know the dudes aren't gonna raise their hand.
You know, there's some guy in the back like, oh yeah.
yeah, that's not that.
And everyone else is like, I thought I was above average.
Yeah, I started out at like 10 inches, and like pushed the limit.
Getting more and more ridiculous.
I think it's up to 12. But I
14.
didn't tell Bantock that was in the slides. So he texted me one day and he's like, did you know that was in the slides? And I was like, yeah, it's true. I don't think that's right.
What are you saying, man?
You gotta test the question.
Yeah, you
So he
need
just
to
put the
explain.
slide up and was like, and then it's 12.
You just like crush like every man's dream in that class. I'll be like more than half.
That's too fast.
And every woman's like, I fucking knew it. I knew it.
All right, reflexes. So
She was
I
going
don't know
for
how
penis
old
like
this
your
link is,
reflexes.
but if it's still good, it has a good video on reflexes.
Let's just demonstrate.
What's
You wanna
that?
have a little, do the knee thing?
DTR, let's, yeah, we can whack on some of these. So
Shut up,
reflexes
Spencer.
are an automatic and rapid response to a particular stimulus. There's cerebral reflexes that remain in the boundaries of the brain and the brain stem. Then there's spinal reflexes that come from or pass through the spinal cord. We'll just talk about spinal reflexes pretty much. Like I said, it's automatic, so it's without conscious control. So you can think of deep tendon reflex where the doctor whacks your tendon, fires stretch receptors, and your knee jerks without your control, right? This is because it's not going initially to the higher brain centers. It's just going through an arc into the spinal cord and then a response back out. So these are rapid protective mechanisms because going up to the brain, integration and back down takes time. It's milliseconds, but when you're in some instance of danger or need to respond rapidly, that extra time can be detrimental. Yeah.
Are there any like lesser known reflex? Because it seems like with the deep tendon one, since everyone knows you're supposed to kick, you see people do it and they like.
Yeah, I mean you have.
They do it without even hitting it sometimes,
Sure. And that's technically any muscle, any tendon that you create a rapid stretch on, you have a reflex.
So you could do it
So
hypothetically.
it's kind of stupid that you would ever check just unless you suspect pathology there, but if you're checking reflexes, like if I think somebody has some sort of nerve dysfunction in their lumbar spine, I'll check reflexes in any of those corresponding dermatomes and myotomes, because you can check the hamstring and the patella and the calcaneal tendon, and those will indicate different areas. So if you have normal reflexes bilateral in all those areas, you don't know, but you have at least some normal nerve function from L1, L2, L3, L4, L5, depending on which reflex you're checking. Because each of those muscles are innervated by a different root area, right? So if the function is normal, if the DTR, the deep tendon reflex is normal at that level, you can deduce that it's okay. But there's other reflexes. There's withdrawal reflexes, pain reflexes, stuff like that. We'll kind of get into those. But there's also like gut reflexes too, right? So you can think about, you smell food, you're hungry, something like that. You can start to have a salivary reflex where you start to salivate, right? That's a reflex. If you consume food and there's a stretch in your stomach, then there's a reflex to initiate digestion and secrete enzymes and secrete other, stomach acids and stuff like that. Those are reflexes too. And those are autonomic reflexes. And somatic reflexes, this is where deep tendon reflex comes in, withdrawal reflex, any sort of motor movement reflexes. So in general, the reflex arc is we have some sort of receptor that's responding to a stimulus. It sends a signal through a sensory neuron to the spinal cord. And then we have a motor neuron sending a response out to an effector organ. Sometimes we can have an inner neuron where there's a little neuron in the spinal cord itself that's going through, or sometimes it'll just go straight from sensory to motor. But this in whole is a reflex arc. So again, you have to have a receptor, sensory neuron, sometimes an inner neuron in the spinal cord. You have a motor neuron going out to the effector.
So is that interneuron, is that the same thing as a commissural?
No, because it's not going from left to right.
Okay, so it has to go, laterally.
Yeah, for
Okay.
it to be commissural.
So what's the impact?
There are commissural tracks that can affect
Lateral dorsal, or?
the other
Ventral.
side. Like if you stimulate a reflex on one side, you can stimulate the opposing one on the other side.
Are there commissural tracts that run ventral dorsal as well? Or are those called interneurons?
Say the question again.
Yeah, so if commissural neurons run laterally left to right, are there frontal or?
Yeah, I mean, you're just talking input output, right? The horns, sensory, and then motor out. I don't know that that satisfied your question, but I think it's.
I guess I'm still formulating. I'll think about it for a little bit.
Okay.
Let it just
So what's the
stew.
impact of the nail in your skin, like the motor response to something like that?
What happens? It's
I mean, it
close,
hurts.
yeah. But maybe what would your reaction be, especially if it was kind of by surprise?
Move it away.
Yeah, withdrawal reflex or pain reflex.
I have to like wave it around.
Wave it around. That's your response.
Hold on. If the stimulus is like kind of internal, would your withdrawal reflex pull it deeper in? Is that like? Because do you spatially know where it is? I mean, if most of it is retracting.
Usually a withdrawal reflex is in the opposite direction of pain.
Oh, okay.
You know, so if it's on the anterior surface, I'm gonna have like extensors going
Okay.
to get it away from that.
Okay.
We'll look into that
If you touch a
in a
hot
second.
stove.
So right now, just think general, right?
That's interesting.
Receptor, input, output to an effector.
So does the reflex arc just the little bend through the,
This whole thing is the arc.
Okay.
This is the reflex arc. All of this. So what are the components of a reflex arc?
Stimulus.
Sensory.
What are the components of a reflex arc? Receptor, sensory, might have an interneuron,
Motor neuron.
motor neuron, effector. That is a reflex arc. So let's do our first so that's generic. Let's do our first real application of this with a deep tendon reflex. So when they bonk you on the knee with the reflex hammer, the goal is to create, you're pushing on that tendon and you're creating a rapid stretch in the quadriceps muscle. That rapid stretch is detected by stretch receptors in the length of the muscle belly, and your body's response to that is this reflex arc. So it's a protective mechanism. So in really for our purposes, you see it a lot like in sporting events, like reflexes to different things that occur. But if you go back evolutionary, when you had to fight for your life or hunt for your food or things like that, that's where these reflexes come in handy. And they're day to day too. You're going down the stairs and your foot slips. You have a reflex that grabs you and pulls your flexors so you don't slip down the stairs, right? Ideally. So these are present in daily activity, but you're going to see it most in athletic or physically demanding stuff. Okay. But so deep tendon reflex, we send this signal of rapid stretch to the quadriceps. That information from that receptor gets sent into the spinal cord. We see here on this side, there's no interneuron. It's just going straight out to motor of the quadriceps. What do you think the signal is going to tell that quad to do? Contract, right? So you have contraction of that quadricep muscle that was rapidly stretched and detected by that stretch receptor. So now you have knee extension. Okay. On the other side of this, we have what's called reciprocal inhibition. So it's also going to send a signal through this interneuron to a motor neuron of the hamstring muscle, telling it not to contract. So if these are both contracting with equal force, what kind of contraction do we have? Isometric, no change in length. That's not our goal in this instance. We have a stretch on the quad. We want to fire that muscle and get our legs straight as rapidly as possible. So it's saying hamstring, don't do anything, quad, go full out. Okay, and then you get knee extension. Again, you can do this the other way. So what if I stimulated the deep tendon reflex of the hamstring?
Deflection.
I would get stretch receptor fired going in directly out to the motor of the hamstring, telling it to contract. And then I would get reciprocal inhibition of the quad, telling it to do nothing. so I can get rapid flexion.
Would that like try and prevent hyperextension sometimes maybe? Like if you're like, whoa, we're going too far, pull it back real quick?
Sure, yeah,
Okay.
yep. Okay, so that's an example of a reflex arc specific to the deep tendon reflex. You mentioned reciprocal inhibition. So this would be a polysynaptic reflex where you're synapsing on multiple nerves, right? So poly meaning many synapses or multiple synapses. So if we just had one, it would just be a simple synapse, right? A single synapse. But since we have two, it's called polysynaptic. We're also using that reciprocal inhibition. So here's another one. This is the withdrawal reflex. So this is an instance where for some reason you're pulling away. Typically it's pain, right? Something painful, some painful stimulus, you pull away from it. So this person's putting their finger in the flame of the candle. And so that reflex arc sends sensory information into the spinal cord, informing of this painful stimulus. Efferent fiber going to the bicep, pulling it away, right? So that's a withdrawal reflex. In this case, we don't see reciprocal inhibition. So it's
I'm sorry, I know you just went over it. The reciprocal inhibition, really, what is the function of that again?
to tell the antagonistic muscle not to fire,
And for what purpose though? I mean,
to prevent an isometric contraction.
Does he have to go back?
to prevent an isometric contraction.
So it actually moves.
Oh.
It prevents it.
Oh, it
from-
inhibits it. Okay, okay, yeah, okay.
Yeah, so it's stimulating contraction of one side, inhibiting of the other.
Right. Okay.
And do we not have that here, just
We do not.
by nature of the muscle?
Right. Yeah.
So you could temporarily arrest contraction of one muscle by initiating the reflex on its antagonist, I guess, or agonist?
Yeah, and there's, right, so there's actually therapeutic techniques, I use this all the time, where you try to use that reciprocal inhibition to try to relax a muscle.
It's really interesting. Okay.
So like, if you guys, like PNF stretching, so have you ever done a stretch where you contract one way and then relax, try to stretch it further? So if I'm trying to stretch my wrist flexors, I can hold that sustained stretch, and I get to kind of a plateau. If I contract the opposite direction for 5 seconds, relax for 10, usually I can get to a new endpoint on that stretch. Because I'm using reciprocal inhibition. I'm creating a fire and a stretch and stimulating also Golgi tendon organs that say, hey, this could become dangerous if we continue to contract through the stretch, so go ahead and relax.
So can you not do that with the bicep and tricep, like the tricep?
Yeah, you could. You can do it. Any opposing muscle. So let's make note of the fact that this is subconscious control, right? When these happen, it's out of our control. You touch something hot, you pull away. You guys ever do that with, probably talking more to the guys here, but you like keep your hand on something hot with your buddy and see who can hold their hand on.
I do that too.
I do that too.
Sorry, it's being sexist.
Yeah.
Yeah,
Women
Jesus,
do
come on,
that.
include the women.
Just kidding.
We do
But yeah,
stupid
it's out
stuff
of
too.
conscious control, right? If that reflex arc fires, you're gonna pull away, you know? Or that stretch reflex, it's gonna cause that to happen. Does that mean you're not in control of those movements there shortly after?
No.
No, you are, right? So you have that reflex arc, let's say you do stimulate DTR of the quadriceps tendon, you kick out, very quickly you have control of it again, right? That's because there's also a signal going up through the white matter columns to the brain, informing it of the situation, and then sending a signal back out to regain control. It's slower than the reflex arc, so the reflex arc is dominant and occurs occurs, but then you regain control. You're conscious of the action that happened. So there's still a signal going to the brain, right? It's still getting integrated, it's still getting analyzed, still sending a response out. However, that arc happens already before that control's regained.
Can you consciously override like a reflex? I mean, a reflex. Like if you know it's coming,
yeah,
and it's
you
like
can to some degree.
Okay.
Right? Yeah. This withdrawal reflex, one of my A&P professors in undergrad was talking about, gave an example of this, and I think it's a good illustration. But so he had a little toaster oven, right? And he was making a bagel or something like that, toasting it. And he reached in to get it out, and he touched the hot surface of the stove. So what it is reflex tube. It'll pull up. So he burned the top of his hand, and then what did that withdrawal reflex? He said he went up and down a few times before he got it out, right? So those reflexes are going. The signal's going up to his brain, but it's taking a little time as he bounces the hand in opposing reflexes back and forth before it gets back down and it says, "Hey, stupid, pull your hand out."
What does it mean if that doesn't happen to you?
If that doesn't happen, you have some issue with the nerve there, right? So again, with deep tendon reflexes, that's a part of a neurologic exam to detect if there's some reflex abnormality. Some people just have different reflexes, so you characterize it as whether it seems within the normal range and also bilateral. So if your DTR of a certain muscle is kind of lame on one side but kind of lame on the other side, it's probably okay because it's symmetrical both sides. Sometimes it can be hard to stimulate. Are you talking to deep tendon reflex?
I mean, I just have really bad reflexes with everything, but including like with flames, like heat and stuff.
Like you have a slow withdrawal.
Like I can leave my hand there.
What if you just like, again, you can kind of override that, but like if you were making ramen noodle, I do this every single time I make ramen noodles. If you make ramen noodles in the microwave and you go to pull the bowl out, you probably instinctively pull away or no. Like if you touch it and it's hot.
Sometimes, but not a lot.
Yeah.
So that's what's weird.
Yeah.
You need to get yourself checked
You're
out.
different, right?
evolution is going to weed your genes out.
So you probably don't have pathology, but you are genetically maybe a little different. Maybe your reflexes are a tad different.
You're a mutant.
I'm Spider-Man. I'm Spider-Man.
That doesn't mean that.
Garrett.
He probably has better.
Sometimes the webs.
You can have hyperreflexia too, where it's over exaggerated. Would you say?
Mine are
Webs.
always-
Webs, yeah, web shooting out. That's web reflex.
Subarachnoid.
Subarachnoid reflex.
Maybe now you could just say
No,
this
so any
is
questions on the
right?
Polar.
Not
Super arachnoid.
on the reflexes, but I just kind of wanted to ask about our next exam since next week's our last week.
Yeah. What about it?
Are we gonna have time to finish
Oh,
it?
we got.
Wait,
Look at Emily's like, oh,
Is there
it's
any-
not time.
So
I just
Monday,
feel like
Monday
we
will go.
started.
Tuesday.